Welcome to This Explainer. Today, we're completely changing how you look at the Cambridge 9618 syllabus. We're diving deep into the theoretical foundations and exam strategies for the peer-to-peer model of network computers. But I want to be upfront with you right from the start. We aren't just looking at what a peer-to-peer network is. Frankly, if you're taking this exam, you already know the basics. Instead, we're decoding exam reality. I want you to adopt a new mindset today. There is no exam paper. There are only patterns. You need to learn to see the code behind every single question Cambridge throws at you. If you've been studying relentlessly, putting in the hours, but those top-tier marks just keep slipping through your fingers, you are absolutely in the right place. We're going to break down exactly what examiners are searching for when they scan your answers. And it's not what you might think. We're talking across the board here. Whether you're looking at syllabus codes 0417, 0478, 0983, 0984, 2210, 9713, or specifically 9618, the underlying matrix of how these exams are marked is the same. So, let's plug in and decode this together. This right here is the absolute golden ticket. This quote is pulled directly from the principal examiner reports, and it reveals a massive secret about how to ace your computer science exams. Read between the lines here. Notice what they explicitly do not say. They do not say that top-performing students memorize every single textbook definition perfectly. No, they highlight adaptable conceptual mastery. Let's look at two hypothetical students taking this exam. We'll call them Alex and Sam. Now, Alex represents a huge portion of candidates. Alex overloads every single answer with raw, memorized computer science facts. If the question is about P2P, Alex instantly writes down all nodes have equal status and expects full marks, but there's zero analysis. Sam, on the other hand, usually rushes, completely missing the command word requirements hidden in the prompt. Both of them lose crucial marks. Why? Because in a complex P2P scenario, regurgitating a definition isn't enough. You need to take that concept that all nodes have equal status and apply it to a completely unfamiliar context. Imagine the exam asks you to design a decentralized file sharing system for a global medical research company, or maybe a distributed blockchain ledger. If you just define P2P, you fail the question. You have to show how that specific concept solves that specific problem. To help you build that adaptable mindset, we're going to walk through the ultimate examiner's blueprint. We'll start with mastering the core P2P principles. Then, we'll unlock the method mark strategy. This is a game changer. After that, we'll dive into critical evaluation and trade-offs. And finally, we will look at how to avoid the classic traps that the examiners set for you year after year. Section 1. Mastering core P2P principles. Because let's be real, before you can critically evaluate the intricacies of a complex, networked system, you absolutely must have a rock-solid grasp of the fundamental building blocks. Every single question you face targets these three distinct cognitive domains: knowledge and understanding, application, and analysis. And here is where students like our friend Sam constantly trip up. Sam reads a question, sees the acronym P2P, and immediately dumps knowledge onto the page. But Cambridge demands logical, structured reasoning over a shallow breadth of knowledge. It is never enough to just know what a peer-to-peer network is. You have to cross the threshold into application. Ask yourself, how does this network actually function in the specific scenario provided? And then you have to push even further into analysis. Why is it functioning this way? What are the implications of the command words in the prompt? When the examiner uses a command word like analyze or evaluate, they are practically begging you to show them the interconnected layers of the system. If you aren't decoding those command words and shifting your cognitive domain to match, you are leaving easy marks on the table. So how do you prove that high-level analysis? Cross-topic connections. This is the secret sauce. The principal examiner reports are practically shouting this at us. Referencing concepts from outside the immediate topic achieves significantly higher marks. It shows you understand the whole matrix, not just one isolated line of code. P2P networks do not exist in a vacuum. When you are explaining how a decentralized model functions, you need to connect it to other areas of the syllabus. For example, let's talk about data security principles. How does the total lack of a centralized server impact the spread of malware across the network? If one node gets infected, how does that peer-to-peer relationship accelerate or isolate the threat? Examiners explicitly state that candidates who build these causal bridges, who can link networking concepts to security concepts or hardware concepts, are the ones who score in that elite top-tier bracket. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's move into Section 2, the method mark strategy. This is where we turn abstract theory into an actionable point-scoring machine. This is where you prove to the examiner that you know exactly how to arrive at the solution. Top students don't just guess. They follow a standardized procedural framework. Think of it like an algorithm for answering questions. We can map this directly to the famous Peel framework: point, evidence, explanation, link. First, you deconstruct the question and identify the command words. That's your foundation. Second, you extract the relevant P2P principles. That's your point and evidence. Third, you select and execute your analysis. This is your explanation, where you dive deep into the how and the why. Fourth, you verify your results, ensuring you've actually answered the prompt. And fifth, you present it in the appropriate format, creating that final link back to the scenario. By following this 5-step structure, you guarantee that you capture every single available mark method. Here's a massive insider tip. Even if your final conclusion has a slight error, showing this rigorous, logical process with clear notations and correct terminology often secures the vast majority of the marks anyway. The examiners want to see your brain working on the page. What's really fascinating is that applying the systematic process for writing exam answers perfectly mirrors the core programming skills you are already developing. You're transforming abstract theoretical models into practical applications. Think about it. When you design an algorithm for data distribution across a complex P2P network, or when you sit back and evaluate the performance of how individual nodes communicate with one another, you are executing the exact same critical thinking loop required in high-level software development. You design your approach, you implement your solution on the paper, you mentally test it against the scenario's constraints, and you evaluate your own performance. Writing a perfect exam answer is, in essence, writing a perfect piece of code. It needs to be clean, efficient, and flawlessly executed. Let's step up to Section 3, Critical Evaluation and Trade-offs. This targets those higher-order cognitive domains we talked about. This is the battleground where A-grade candidates truly separate themselves from the rest of the pack. If you want top marks, you must become obsessed with metrics. Top-scoring candidates analyze trade-offs, they openly acknowledge system limitations, and they heavily justify their design decisions using precise evaluation criteria. Let's do a quick mental challenge, a data scan. Imagine a massive P2P network. You have to evaluate its time complexity. How fast is the decentralized search algorithm propagating queries across the nodes? Next, you evaluate space complexity. How much memory and processing power is being consumed locally by each individual peer? And then, the absolute most critical part, edge cases. What happens when a highly connected supernode suddenly drops offline? Or what happens when the network has to scale instantly to accommodate 1,000 new users in 5 seconds? You have to prove to the examiner that you understand the system's limits and boundary behaviors. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now let's talk about comparative analysis. Very often, examiners will ask you to evaluate alternatives. The classic example is comparing a client-server model to a peer-to-peer model. Here's where students lose marks. They just list the pros and cons of P2P, and then list the pros and cons of client-server, and then they just stop. That is not an evaluation. You must balance both sides. You have to explicitly identify similarities and differences using comparative connectives, words like whereas, conversely, on the other hand, or in contrast. Your final conclusion must be a highly justified decision based on the evidence you've presented. If you had 30 seconds to write a perfect Peel paragraph comparing these two, your link sentence must definitively state why one architecture is superior for the specific context provided based on the comparative analysis you just built. Moving to our final section, avoiding classic examiner traps. We've spent a lot of time looking at exactly what you should do. Now let's expose the most common pitfalls that cause students to hemorrhage easy marks. The examiners actually publish their biggest frustrations every year. It's literally a cheat sheet of what not to do. Here are the top 3 warnings. Trap number 1, using the wrong formula or algorithm for the context. This happens when you try to force-fit a memorized solution into a scenario where it doesn't belong. Trap number 2, forgetting your boundary conditions and edge cases. Like we discussed earlier, if you only test the happy path where the P2P network works flawlessly, you aren't doing real analysis. You have to account for failures and extremes. Now, these first 2 errors are purely methodological. They are completely preventable if you stick to the framework. But trap number 3 is the ultimate killer. Trap number 3 is providing generic context instead of context-specific analysis. This is the ultimate examiner alert. Never, ever provide just generic facts. You must always link every single point directly to the specific scenario provided in the question. Let me give you an example. Let's say the exam scenario asks about a high school setting up a localized peer-to-peer network for a new multimedia computer lab. If you write a beautifully structured paragraph about P2P networks, but you never once mention the students, the specific multimedia lab environment, or the unique constraints of a school setting, you are going to lose significant marks. You have to blend your technical knowledge with their specific reality. If you don't anchor your answer in their context, your answer is technically correct, but academically useless. So we come to the ultimate metacognitive question. Are your answers just stating facts, or are they actually solving the scenario? I want you to look at the last practice paper you did. Did you just dump a bunch of memorized facts onto the page like Alex? Or did you decode the command words, use the PL framework, and actually solve the unique problem? Let's recap the ultimate system. Rule 1, command word decoding. Rule 2, flawless PL framework application. Rule 3, time management matrix, allocating your time based on the method marks available. In computer science, knowledge without application is just wasted storage space. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.